Rates. I think that most level 1 candidates find this reading a little more challenging than most of the other readings in the fixed income material. So the stuff here is not particularly difficult, but there's lots of exponents and that sort of thing, especially when we're dealing with forward rates and spot rates. Talked about spot rates previously so we could interpret a problem. Here we're actually going to look at the calculation, where they come from, what the logic behind the spot rate is. And what I think drives people crazy more than anything is moving back and forth between spot rates and forward rates. So that is maybe a little more challenging. I think you'll find that if you, one, get a good handle on what is the difference between a spot rate and a forward rate, and then two, practice this just a little bit, I think you'll find that it becomes fairly easy. So it's not the easiest thing in the curriculum, but a little bit easier. All right, so sources of bond return. So three sources here in terms of bond return. We are, of course, going to get interest on the bond. If we bought the bond at anything other than par value, then we're going to either have a capital gain or capital loss when it repays. So remember, it doesn't matter what you buy the bond for, you're always going to get the $1,000 back. So you can buy it for $1,100, you're going to get $1,000 back. You can buy it for $800, you're going to get $1,000 back. So there is the capital gain or loss, depending on whether we bought it at a premium or discount. And the one that people don't think about is this last one, and this is actually going to get some significant play in this reading. That is the idea of reinvestment rate risk, or reinvestment of the cash flows. So to understand this, make sure you understand that implicitly what we assume when we talk about the return on a bond is that if we have cash flows that come at three different points in time, so we get time 1, 2, and 3, we're going to end up calculating the return on a bond. And it's going to depend on all three of these things: coupon interest, gain or loss, and then reinvestment of cash flows. So if we had a bond that had $100 cash flows each year for 3 years, those are the interest payments, and then a return of principal of $1,000, the measure that we're going to use, the most common measure, that is the internal rate of return based measures, assume implicitly, okay, so it may not seem obvious to you, but the mathematics of this assume that you are going to take this $100 that you get at time 1 and you're going to reinvest it at that yield, whatever the yield that we calculate on the bond is, until we get to time 3. When you get the cash flow at time 2, you're going to invest that also at the yield until we get to time 3. And then, of course, the time 3 cash flows are invested for 0 periods, so they're just sitting there. There's no reinvestment of those last cash flows. But this reinvestment of the interim payments is part of the return that goes into the calculation of the internal rate of return based measures. So reinvestment rate risk, or reinvestment of the cash flows for a long-term bond, can be quite substantial and can be a big part of the return. And if you're not able to reinvest these, suppose we find that the yield is equal to 11%, right? So that's the yield on the bond. Well, if you reinvest these exactly at 11%, okay, then if you hold it to maturity, there's no default, you reinvest exactly 11%, then you'll get an exactly 11% return. But what if you can only reinvest these at 4%? Okay, well, then you're not going to earn this yield that we calculate. So it's dependent on us being able to reinvest the cash flows at this yield, or at the internal rate of return on the bond. So important point, something I think is highly testable and something that you will want to make sure you have your head around. Anyway, so traditional yield measures. The traditional yield measures, the nominal yield, that's just ink stains, so that's just the coupon rate. So if it's a 6% bond, then the nominal yield is 6%. The current yield, okay, we're going to define that later, but the really important thing about the current yield is to realize that when we say current yield, we don't mean the current yield to maturity, all right? So the one we're going to spend our most time talking about here is yield to maturity. These are all of them that you see here in this little weird-looking shape thing. Looks like a house turned on its side. Is our internal rate of return based measures. Now, these internal rate of return calculations show up everywhere in finance. We've been talking about them now for a long time if you've gone straight through all the study sessions in this video series. So this is a very common type calculation where we relate the value of the cash flows today, a known, to the cash flows that we expect to come in, and we're solving for the rate that links those two. That's what we mean by internal rate of return. That is, the return is internal to the cash flows. So yield to maturity is the sort of prime example of this, but we'll see that there's others also. So we can talk about, yield to when the bond is callable or refundable or when it's puttable. The yield to worst actually doesn't have a calculation to go with it. We'll talk about why. And then a cash flow yield just pertains to a security that pays monthly cash flow. So really, the top one and the bottom one inside the little house here are the same calculations, just that one of them assumes payments are monthly. The other assumes that they're either semi-annual or annual. So yield to maturity, big deal. Okay, and the thing you have to remember is that current yield is its own term, right? That doesn't mean current yield to maturity. So make sure you keep those two things straight. We'll define all of these, but let's start off talking about yield to maturity since that's our prime measure. So in the last reading, what we did was said, hey, we know the cash flows and we know the discount rate. All right, so what we wanted to know in the last reading, okay, was the price of the bonds. So they told us, oh, well, the discount rate's going to be, 16%. And we would just plug in 16% and we discount it back and we'd find the value of the bond. Okay, well, this time we know the value of the bond because we can observe that in the market. We know the cash flows because these are all contractual cash flows, right? So the interest payments and the return of principal. So we are solving for the yield to maturity. Now, there's not a closed form solution for this. It has to be done with trial and error. Luckily, your calculator will, the makers of your calculator knew you would be doing this problem if you're taking the CFA exam. And so they programmed it so that it will do lots of trials, absorb the errors, and give you a very accurate answer. So what this boils down to, all right, if you went through the last reading, you understood the 5, find, 4 game. That is, you enter the 4 things you know, and you solve for the 5th on your calculator. So you enter the 4 things you know, you solve for the 5th. This is the same thing, only now, instead of solving for the price, we're solving for the yield, all right? One safety tip here is that when you're dealing with bonds, you've got to put the present value in as a negative. That's not strictly speaking true. We could, so, if you buy the bond today, you're going to pay $943, okay, and then you're going to get $60 every year and get $1,000 every year. We could have looked at this from the company's point of view, if you want to think of it that way. They're going to be paying $60 every year and paying $1,000 at the end, but they're getting $943 today. So we could change the signs, but I think it's just a lot easier to remember that when you're dealing with bonds, enter the present value as a negative. All right. So what are the 4 things we know about this bond? Well, we know that the present value, $943, we're going to enter it as a negative. We know that the payments are $60. We know that the face value is $1,000. We know that there's 3 years to maturity. We're going to plug that in, and we're going to get a yield to maturity of 8.22%. That is the yield to maturity, or YTM. Okay? It is the current yield to maturity, but it is not the current yield. It's also sometimes called the promised yield. So if you, under the set of assumptions that we saw on the last slide, that is that you hold it to maturity, that there's not going to be any default, all those types of things, the reinvestment risk, the reinvestment income is perfect, then you would earn 8.22%. So the promised yield is another name, but I think the yield to maturity is much more common. Now notice that this sells for below its par value. Why is that? Okay, well, that's because the yield to maturity, okay, at 8.22% is greater than the coupon yield. So we're taking the cash flows out at 6 and we're discounting them back at 8.22. So we're going to end up with a value less than 1,000. And that's one of our prime pricing sensitivities that we talked about. And that's our pencil trick, right? So in this case, we said, hey, the interest rates have gone up since the bond's been issued. You can think of the coupon yield or the coupon rate as being something about equal to the required return when the bond was issued. In this case, it was 6%. Now interest rates have gone up to 8%, so the value of the bond has, of course, gone down. So the pencil trick there still works. Always works, in fact, when you're dealing with bonds that were issued previously. All right, so that is the yield to maturity for an annual pay bond. Emphasis in that statement on annual. What happens if we change this to semi-annual? Well, now we're doing the same thing. Okay, that is, we're going to get half of the coupon payment after 6 months and another half after 12 months and so forth. At the end, we're still going to get the return of principal. We have to remember that we're going to be discounting these back for semi-annual periods. So we're going to take the yield to maturity and divide it by 2. We're always going to state yields on an annualized basis. So they're going to give you yields on the exam on an annualized basis, and they're going to expect you to give them answers stated on an annualized basis, except in the rarest of circumstances when there's lights flashing and they're really asking for what would be called a periodic rate, right? So in this case, we're going to say we know the price and we know the coupon payments, we know the par value, we know the N. What we're going to do is solve for the yield to maturity, all right? Now notice the way this is structured. What we're solving for actually is the yield to maturity divided by 2, right? We're solving for a semi-annual interest rate here. So looking at an example, we have a 3-year 5% treasury note priced at $1,028. So what do we know? Hey, the present value, we're going to enter that. That's what you buy it for today, minus $1,028 out of your pocket. The future value is going to be $1,000. There are going to be payments of $25. How do I know that? 5% times $1,000 par value. That's $50 a year. Divide by 2. Because this treasury security, really we don't even need to put semi-annual in this heading. Why not? Because when they say treasury note or treasury bond, they're going to expect you to know that it has semi-annual payments. Right? So anyway, we're getting $50 a year. That's $25 every 6 months. And we're going to have 6 of those semi-annual periods. And the problem that you're going to face is that if you go in and you know all how to do this, you find the 4 things you solve for the one you don't, okay, you end up with, hey, here's the yield to maturity, 2%. You're going to look down. That's going to be answer A. You're going to see it on your calculator. You're going to see it on your test. And then you bubble in A and you happily fail the exam. Remember, what you've solved for here is a semi-annual yield. The way we get that to an annualized yield with bonds is we multiply it by 2. That's what's called a BEY, a bond equivalent yield. So it's an effective yield over 6 months multiplied by 2. And the reason we have a special name for it is because there's so many, the bond market, and in particular the semi-annual pay bond market, is so huge that we'll often want to compare other securities to bonds. To be able to have an apples and apples comparison, we may state other things on a bond equivalent basis. And we'll see a few problems with that, with dealing with this as we go through. So the bond equivalent yield for a short-term security in corporate finance reading is a little bit different. Okay, this is the one that I would focus on for the purposes of the exam. So here we go. Let's make sure, since we've already talked about this going way back to study session either 2 or 3, an annual pay bond has a yield to maturity of 14%. So it's an annual pay bond. So we solve for this. We solve for it in one step, 14%. What is a bond equivalent yield? So in other words, what is this bond, the BEY, okay, that would give us 14% per year? Right? Well, is the first thing we can ask, is it going to be higher or lower than 14%? If it turned out that the bond equivalent yield was higher than 14%, then we'd know the answer was C, right? So we wouldn't have to do any of the calculations. And if we know that it's lower, but we don't know how to get it, well, then we can at least get it down to where we're guessing only 1 out of 2. That's pretty good, right? You got a 50-50 shot, so just knowing which way that goes is going to be important. But remember, as we increase the compounding frequency, okay, then we are going to we're going to increase the effective yield on the bond. This is stated annually, so it's already an effective yield. So the question is, what is the semi-annual yield that we can multiply by 2 that is going to give us the same effective yield as 14%? So we're going to take that 14%. We are going to take the square root of it. So 1 plus 1.14, take the square root. So that's going to tell us how much we would have to have each semi-annual period. Notice that it's going to be less than 7%. We're going to subtract off the 1, so to get rid of the 1 that we added in here, right? So this is what we're really working with is 14%. We added in the 1. Okay, then we multiply that by 2, and we get this 13.54%. Make sure that you understand that 14% on an annual basis, okay, is the same as 13.54% on a semi-annual basis. That is, so the effective yields here are the same. The BEY of 13.54 gives you exactly the same return as annual compounding of 14%. Okay? All right, current yield. So I've cautioned you about this very up front, in terms of that it's a different concept. So we're not talking about the current yield to maturity. The current yield is its own thing. The current yield is actually a throwback to to the pre-computer era, when it was, if you have to do this yield to maturity calculation by hand, remember there's no closed form solution for that. Okay, so you've got to do all those trials and errors, and if you worked for the Wall Street Journal and you're doing that in 1940, then you had all those bonds showing up in the bond pages that needed a yield measure every day. Okay, well, without a computer, going through and calculating that yield, doing the trial and error would be a real pain. So they came up with an easier measure. It's an artifact of something just that simple. So the current yield is just the annual coupon payment divided by the current price. So if the bond's trading at par, the current yield, the stated yield or coupon rate, and the yield to maturity are all the same. For any other price, for if it's trading at a premium or trading at a discount, okay, well then you are going to end up with a current yield that is different than the stated yield and different than the yield to maturity. So if you have an 8% 3-year semi-annual pay bond priced at 901, we've got an annual coupon payment in the numerator. Doesn't matter if it's semi-annual pay or anything else, you put an annual coupon in the numerator, divide it by the current price, and what you get is 8.873. The yield to maturity on this is actually 12%. So what we see is that the stated rate or the coupon rate is 8. Okay, the current yield is 8.873 and the yield to maturity is higher than that at 12%. The reason is the current yield does not account for movement towards par. You're going to buy this bond for 901.65, but when it matures, you're not going to get 901.65. What are you going to get? You're going to get the 1,000, right? So you're going to have a capital gain. That capital gain is not included in that yield measure, the current yield. It is included in the internal rate of return or the yield to maturity. So you get a much more complete measure of yield when you look at yield to maturity. But notice when we had bonds trading at a discount, okay, we see that we get the coupon rate is lower than the current yield, is lower than the yield to maturity. Okay, and we can think about that on the next slide because it's going to say for a bond trading at a premium, order the coupon yield, okay, the current yield and the yield to maturity from smallest to largest. Okay, so what's going to happen? The current yield, remember that's just annual coupon divided by the bond price. For a premium bond, the price is greater than par, so the current yield is going to be below the stated yield, right? Got a big denominator. So the current yield is less than coupon. Okay, the yield to maturity is less than the current yield for the premium bond because, again, you have this movement towards par, which is going to be negative. So the way I think about this, and I don't think this is a very nifty graph, but if you think of it as, here is the coupon rate. Okay, so I'm going to call, nope, I'm not going to call that the current yield. So this is the coupon, whatever that happens to be. Okay, well, if we have bonds that are selling at a discount, so discounts over here, okay, and premium bonds are over here, well, then as we move into the discount bonds, we're going to have the current yield, and then higher than that is going to be the yield to maturity. Okay, and if we go into premium bonds, we'll see the current yield is lower, okay, and the yield to maturity is lower still. So what you need to remember, well, that's supposed to be yield to maturity. Wow, that's really a sloppy writing. Okay, that's supposed to be an M there also. So what you need to remember is that the coupon rate doesn't change, okay, and the yield to maturity is always going to be on the ends. That means that the coupon or the current yield has to be in the middle between them, right? So this doesn't change unless a bankruptcy judge changes it. The yield to maturity is the one that's going to swing the most. If you'll think about that, then questions like ordering these things become, I think, quite easy. All right, so that's current yield measures. Now, what about some more of these internal rate of return-based measures? The most important here is probably yield to first call or yield to refunding. Remember, bonds can be callable but not refundable. So you can call after 5 years, but it's not refundable, means you can call the bond, but only if you can pay for it out of operating profits. You can't issue another bond, okay, that is to refund the loan. So the common mortgage finance instrument in the United States is either a 15 or a 30-year loan. People talk about refinancing. Well, that's effectively refunding. So you're going to pay off the old loan, and you're going to do that with the proceeds from a new loan. So that would be refunding. If mortgages were callable but not refundable, that would say, sure, you can pay off your home loan anytime you want, but only if you can do it out of your income. You can't borrow any money to do it. You can't borrow any money within 6 months of when you do it, something along those lines, all right? So for yield to first call, this is really easy. All we're going to do is substitute the call price at the first call date for the par and the number of periods until the first call date for in. Do the same thing for refunding. So all you're doing is saying, well, we can calculate the yield to maturity on this 20-year bond. Okay, we can also say, well, what if the bond's callable after 5? refundable after 10. You just treat the call provisions or the refunding provisions like they are the terminal provisions of the bond. So you just plug those in, and that will tell you the yield to first call or yield to refunding. There's also this thing called yield to worst, and all that says is that you're going to go through and you're going to find the lowest of the yield to maturity and all the yield to call dates given the call dates and prices for those bonds. And we'll get a little bit of an example for that right here. So anyway, looking at this, the first part here is not anything new. All we're doing is calculating yield to maturity. So this is just the 5, find, 4 game based on maturity parameters, just like we've talked about over the last number of slides. Okay, so we're looking at a 10-year, 5% bond priced at $1,028. What's the yield to maturity? Now notice what we do here. All right, so we're going to calculate the yield to maturity, but what are we going to plug in for N? Okay. Well, in this case, it would have been, it would have been nice if we had said, oh, let's do this as a semi. Okay. But I think that the assumption of semi-annual yields is in fact the default setting here. So that's the way I would treat the problems on the exam. So N is equal to 20, the payment's equal to 25 because it's got a 5% coupon, future value of 1,000, the price of 1,028. When you do all that on your calculator, okay, what you're going to get, okay, is that you get a yield on your calculator of 2.323. Again, if you're not careful, you see it on your calculator, you see it on your test, you bubble it in and you move along, right? You get confirmation that your wrong answer is right. You've got to remember to multiply that by 2 to get the yield to maturity here of 4.646%. Now, that's just a standard YTM, so we haven't done anything new here, but now let's calculate a yield to call. So let's assume the bond is callable in 2 years at 101. 101 means 110% of par. That says even though the firm issued these bonds, they have 10 years till maturity, they can call them back 2 years from now if they pay a 1% premium. So 100%, if it was callable at 100, then there would be no call premium. So this is a 1% premium over their face value. So for a $1,000 bond, that's going to be $1,010, right? So all we're going to do is pretend like the bonds are going to be called in 2 years, and that instead of having a $1,000 face, they're going to have 101% of par, or $1,010. So 2 years, that's 4 semi-annual periods away. Payment doesn't change. The future value now, 1,010. The present value, of course, the market price is what it is. We end up here with a yield of 2.007, but what are we going to do? Remember, we've got to multiply that by 2 to get 4.014. So we have a yield to maturity, we have a yield to call. What's the yield to worst? Well, the yield to worst just says look at all the yield to call, all the yield to maturity, and find the lowest one. So this is the yield to call. It's also the yield to worst in this case. So yield to worst by itself doesn't have any explicit calculations, just a comparison of the other calculations that you've already made. Okay, what about yield to put, cash flow yield? So yield to put, this is the same thing as a yield to call, only now instead of looking at when is the bond going to be callable, we're going to look at when it's puttable and at what price can we put it. So you may have an arrangement with the firm that is something stated in the indenture, the document that controls the bond, that you can put this bond back to the firm for $990 anytime after 5 years or something like that. So all we're going to do is plug in the put price for the par value. We're going to plug in the put date for N and do just what we did with yield to call. Cash flow yield, a little bit different. This has to do with this exact same calculation as yield to maturity, only it's going to be based on 12 payments in a year. So we don't see it much at level 1, although it's mentioned in a couple of places. You will see a lot of it at level 2, where we're going to go and look at asset-backed securities. So mortgage backs, or something's backed by credit card receivable, something along those lines. Well, those typically have monthly cash flows, so you have a yield to maturity based on monthly cash flows. Well, we call that a cash flow yield. I don't think we'll be calculating those much at level 1. Okay, assumptions, limitations of traditional yield measures, and by traditional here, what we really mean is yield to maturity. So what is the assumptions? Well, it assumes that we're going to hold this till maturity. So we don't have price risk. We're buying it today for whatever it is. We're going to hold it till it matures at 1,000. It, of course, assumes that the firm doesn't default. it assumes that the cash flows can be reinvested at the computed yield, which is what we talked about on like the second slide in this reading. And that effectively makes the assumption that the yield curve is flat. So you get a yield to maturity of 9%. It assumes on a 20-year bond, you get the first cash flow, you reinvest it at 9%. The second, 9%. The third, 9%. So the yield curve is flat and constant in order to actually get this promised yield. So that's a lot of assumptions, and that's why the promised yield, like I said, should probably be called the broken promised yield, because you're probably not going to earn exactly that, if for no other reason because of the reinvestment stuff, right? So some bonds have more reinvestment risk than others. So what's going to make bonds have high reinvestment risk? Okay, well, the reinvestment risk is going to be higher if you have lots of interim cash flows to reinvest. That is, if you have high coupons. So if you look at a 10% coupon bond versus a 3% coupon bond, the higher the coupon, the more cash you have to reinvest over the life of the bond, the more dependent the yield is going to be, that is the yield to maturity, the more dependent the yield to maturity is going to be on the reinvestment income from the bond. Also, the longer time you have to reinvest over. So if you got a 2-year bond, okay, even if it has high coupons, well, you don't make a lot of money investing coupons over 1 or 2 years. But if you have a high coupon 30-year bond, okay, then you're going to have lots of reinvestment risk. Okay, what if you have a 0 coupon bond? Well, then you don't have any interim cash flows, so you don't have to worry about reinvestment risk with a 0 coupon bond. All right? Okay, what about annual pay yield to maturity to semi-annual pay yield to maturity? We've already really done this in our little problem we looked at. But if we have an annual pay yield to maturity is 8%, what is the equivalent semi-annual yield to maturity? That is, what is this BEY? So you have a security that makes annual payments of 8% at a yield of 8%, not makes payments of 8%. You have a security that makes payments annually, has a yield of 8%. Well, what is the equivalent bond equivalent yield? One too many words in there. So what would make us as well off if we stated the return on a semi-annual basis, multiplied it by 2? That is, what would be the bond equivalent yield? Well, again, we're going to take 1, we're going to add the annual yield, we're going to take the square root of that and then subtract back out the 1. Okay, so all that tells us is what is the semi-annual yield? Okay, well, it's going to be less than 4%. Why? You don't need to earn 4% in the first period and then 4% in the second period to get up to 8% over the year. Because if you have compounding, okay, well, you're going to get your interest at 6 months and then earn a little bit more interest in the second period, right? So that tells us that we're going to get something a little less than 4%. So the semi-annual, or the BEY, or the semi-annual yield to maturity would be 7.846. Make sure you understand that earning 8% annually or earning 7.846%, subject to a little rounding error, or earning 7.846% on a semi-annual basis is exactly the same. Right? So there's no difference in what we've earned there. So that's annual pay to semi-annual. What about going the other way? So what if we want to go from a semi-annual yield to maturity to an annual yield to maturity? Well, now we have a semi-annual bond, okay, where we've calculated the yield to maturity to be 8%. That's automatically stated on a BEY basis. That's where we get BEY, right? We took a semi-annual pay bond. We calculated the yield. That was a semi-annual yield. We multiplied it by 2. What would be the annual pay equivalent? Okay, well, what that says is the semi-annual yield is 4%. So how much are you going to have to earn over a year to be as well off earning 4% in the first period and 4% in the second period? Well, obviously, because of the power of compounding, you're going to have to earn a little more if you're just compounding annually. So we're going to take this 8%, divide it by 2, okay, add in the 1 to make the math work, okay, and then we're going to square that, and then we subtract back out the 1. So we add it in here, we subtract it out here, and what we get is 8.16%. So once again, earning 8% compounded semi-annually, earning 8.16% compounded annually gives us exactly the same outcome. So moving back and forth between semi-annual pay and annual pay, I think that's likely enough on the exam that I'd make sure I knew how to do it. Okay, let's talk about spot rates for a moment. Okay, so and I'm going to get rid of a little bit of this stuff so that we can focus a little more on what we're doing before we jump into this somewhat tedious example. So what we have here is we have a 6-month bond and a 1-year bond. We also have an 18-month bond, but I don't want to worry about that one just yet. So if you have a 6-month bond, then, you've got, we'll call that a half a year. So we've got time 0 here. and that takes us to, 0.5 years over here. We know in this case that this is a Treasury security and it happens to be a bill. So we have a T-bill, which means it's a pure discount security. So we know we're going to get $1,000 here. We know that the price of the bond over here is not, well, should set 1,000. Okay, so getting rid of that. So we're going to get, since they've got it stated for hundreds, well, no, they do have it stated for thousands. All right, sorry about that. So they've got $1,000 here when the bond matures. And today we're going to get the price of, we're going to pay the value of $9.83 for the bond. Well, remember, since this is a half year, this is a 6-month spot rate. Right? So that's a 6-month spot rate because there's no interim cash flow. So if you can calculate the yield between these two, the $9.83 that you're paying for the bond today and the $1,000 that it matures at 6 months from now, that is a spot rate. Remember the definition. A spot rate is a rate you use to discount a single cash flow from some point in the future back to today. So in this case, we can go in and calculate the spot rate and we get 1.73% as the discount between these two. If we state it on a bond equivalent basis, it'll end up being 3.46. All right. Now, here's the point I want to make. I'm going to get rid of some of my chicken scratch there. So when we looked at this first bond, okay, it had cash flows that came, at time 0 and time 1/2. The second bond, okay, that is the 1-year bond, okay, is going to have a value today at time 0. It's also going to have a cash flow that comes half a year from now because it is a Treasury security, and then a return of principal at 1 year, right? So in this case, we're going to get, $1,000 here. Okay, and for the 6-month bond, and we'll get the parameters of it later on, but for the 6-month bond, we're going to get some sort of payment here, and then we're going to get that same interest payment plus $1,000 here, right? Well, does it make any sense if we said the yield to maturity on this bond was, X, and the yield to maturity on this bond was Y? So remember, yields you're using to discount all the cash flows at a single rate. Okay, and that's supposed to say payment, not put. It looked more like put. Anyway, the point is, if these rates are different, which they are unless the yield curve is flat, then we have the payments coming from the same issuer at the same time that we're discounting at a different rate. So all we're talking about here is a process called bootstrapping. And that says if we know the first spot rate, okay, then once we can take that spot rate and apply it here, so we'll know, the price of the bond over here, okay, we know the first spot rate, and then we can find the second spot rate. So bootstrapping, this is used in a number of areas in finance and statistics. It says if you can find the first one, in this case we're talking about spot rates, then you can find the second one. If you know the first two, then you can find the third one. If you know the first three, then you can find the one after that. You can find the fourth one. So that's all we're doing with this bootstrapping process. So looking at the value of the bond, okay, we get the bond that's trading at $98.30. That's the present value today. Then we're going to say, well, what's the discount rate? We solve for that. We get set 1.73%, or on a bond equivalent basis, 3.46%. Now, looking at the 1-year 4% Treasury note, it's priced at $99.50. Okay, so $99.50 says what? Well, if I know that this is going to have cash flows at time 1 of $20, time 6 months of $20, time 1 year of $20, well, I already know from the example up here, I know what I should discount the cash flows that come 6 months from now for this issuer. I should discount those at 3.46% or 1.73% stated as a semi-annual yield. So I know the present value, okay, the price, $9.95. This is a constant, right? So $20 divided by 1.0173. The only thing I don't know in this whole formula is this. Well, if it's one equation with only one unknown, in this case this 1-year spot rate, then I ought to be able to solve for it. And the rest of the red writing here is just solving for it, right? So we're going to, what are we going to do? Well, this is just a number and this is just a number, so we're going to get those together. Okay, then we're going to get this all by itself over here, and we're eventually going to solve, and we're going to get the yield should be 2.26%, but that's a semi-annual yield, so we got to remember to multiply by 2 to get 4.52%. All right, so anyway, so we end up here with this 2.26%, 4.52. Now what do we know? We know the 6-month spot rate, and we know the 1-year spot rate. So now we can take that and say, well, what about the 18-month spot rate? Well, if we have this 18-month bill, it's got a 4.5% interest rate or coupon rate, so we can calculate the cash flows. It's going to be $22.50, $22.50, $1,000, $22.50. We know the 6-month spot rate. We know the 1-year spot rate. Where are we back to? Once again, the only thing we don't know is the 1.5-year spot rate since we're given the market price. So we're just going to solve for that. And all this stuff down here is just algebra, and you can look through that to the extent that it turns you on. So anyway, this process is called bootstrapping. And what we're calculating is the spot rates. And these spot rates are the rates we're going to use to discount a single cash flow from some point in the future back to today. So we have a 6-month spot rate. We have a 1-year spot rate. We have a 1.5-year spot rate, all the way up to 30 years or however long the spot rate curve has been generated for us. So anyway, that is the process of bootstrapping. I think this process of bootstrapping spot rates, that is certainly something that could show up on the exam, but it is far more important that you understand what a spot rate is, even if all of the algebra stuff here is something that you don't particularly like dealing with. So we can calculate these rates, but being able to use them is even more important. So here's an example. We take these spot rates from our last example. We have a 5% 18-month Treasury note. Well, what's the value of that today? Well, if it's a 5%, that means we're going to get $25 each 6 months. So $25 6 months from now, a year from now, and 18 months from now, plus the $1,000 return of principal. Here's the spot rates we just calculated, again, allowing for the semi-annual nature of these rates. Okay, that tells us that the value of this bond should be $993.09. That's what we did in the last reading when we talked about using spot rates to value a bond. All we've really added here was the calculation of the spot rates, right? So, but you got to know what those spot rates are, because there's going to be some things, in order to understand them, you're just going to have to understand the spot rate curve, all right? And one of the important things for you to understand is talked about in these next couple slides, that is spread measures. So what happens here is we don't talk about bond returns, or at least bond traders don't frequently talk about them as, oh, the yield to maturity is 4.2%. We talk about them as spreads, right? So the easiest spread is what's called the nominal spread. So the way we would do that is we just say, okay, we have a bond that has a yield to maturity, whoops, that's a Y, a yield to maturity equal to, I'm going to call it 5%. We would look at a comparable maturity treasury, I'm just going to put a T, and we'd see that that's going to be, 4%. And the nominal spread is just the difference between these two. It's just the difference between the yield to maturity on the comparison, okay, this is frequently done as a comparison to treasuries, and the yield to maturity on our bond, all right? Now the problem with the nominal spread is that there's lots of things that it doesn't account for. In particular, it doesn't account for the shape of the yield curve. It also does not account, well, I guess it's easier to say what it does account for. The only thing it accounts for is yield. It doesn't account for the shape of the yield curve. It doesn't account for any changes in the cash flows from the bond because of optionality. If I were doing the curriculum here, I would have you understand the nominal spread and the zero volatility spread and be able to think about those. We're going to add one on the next slide called the option adjusted spread. And the problem with that is we really don't know enough in the level 1 curriculum to be able to talk about it very rigorously. So what I'm going to suggest you do is get a good handle on the nominal spread. That's easy. Get a handle on the Z spread. We're about to talk about that. And then just sort of learn or memorize a few things about the option adjusted spread. We'll get back together in a few months after you get past this level 1 exam and talk about the option adjusted spread in more detail. So the Z spread, okay, the zero volatility spread, or if you're in the UK or Canada, the Z spread. So this is the spread to the Treasury spot rate curve to get the present value to equal the market price. So let me give you a quick example of what this means, all right? And I got to turn on the right tool. Okay, so here's what we're doing. So we've got this spot rate curve that we've generated, right? So we went out, we took a bunch of Treasury securities, we looked at time, we come up here and we get the spot rates, and we get spot rates that look like this, all right? So here's our spot rate curve. Now what we're going to do is we're going to take these spot rates and we're going to go out and say, well, what is the price what's the present value for our AA bond, all right? So we take the cash flows from our AA bond, we discount the, we'll assume this is annual. So there's a 1 year and the 2 year spot rate and the 3 year spot rate and the 4 year spot rate. We discount all the cash flows and what we get is a price of, I don't know, $9.87, right? All right, so that's great. We took all these cash flows, we discounted them at the spot rate, and we got a price of $9.87. Well, the trouble is that we went and we opened the newspaper, right? So we got the market price, and we saw that the market price was, $9.71. Well, why did we get a value of $9.87 when the market price was $9.71? Well, what we need to do is we need to, well, first of all, clean up my example here a little bit. Okay, so looking back, here's our spot rates again without all the chicken scratch associated with them. Okay, well, the problem is that spot rate curve is sometimes called the theoretical spot rate curve for treasuries. So this AA bond has lots of default risk, and we're comparing it to treasury securities, which are, well, at least for curriculum purposes, default free. Fill in your own downgrade joke. Anyway, so the present value is, for the AA bond, if we're using treasury securities, of course we're going to get a rate that's too high. So what we can do now is we can go in and we can say, well, let's take these spot rates and add just a little something to every spot rate, all right? So maybe we're going to add 50 basis points. So then we're going to go back and say, well, let's take the present value now for our AA bond. Here's present value for our AA bond with the spot rates, but for every spot rate we've added 50 basis points and we get $971. Well, what's happened? Okay, we've taken this and we've said take the spot rate plus 50 basis points. Okay, well, this 50 basis points, that is the spread we have to add to every spot rate on the theoretical spot rate curve to force the model price to be equal to the market price. That is our z-spread, all right? So the z-spread, we start with the theoretical spot rate curve, okay, and we keep adding to each of those spot rates, the same amount to every spot rate. In this case, we did it in one step, so it's an iterative process. We could have added 30 and then 40 and then 50. But jumping straight to the answer, we add 50 basis points. When we take the theoretical spot rate curve or the theoretical spot rates, we add 50 basis points to all of them. That makes the model price, the present value calculation, equal to the newspaper price or the market price. Well, then we have found the z-spread or the zero volatility spread. So this is the spread, okay, that when we add it to every spot rate, so the spread that we're going to add to the theoretical spot rate curve for treasuries so that the present value is equal to the market price, okay, well then we have found the z-spread, all right? Now the z-spread, if you're talking about a short-term, relatively flat yield curve, then the z-spread and the nominal spread are going to be very close. But the steeper the slope and the longer the term of the bond, the more those two terms will diverge. And what we're ultimately going to say is that the nominal spread just isn't much good. You can use the z-spread if you don't have any options in the underlying bond. But if you do have options, then you've got to use this thing, the option adjusted spread or OAS. And like I said, we really haven't studied optionality in bonds, and it takes some doing to get on top of. In fact, I would say the central change between level 1 fixed income and level 2 fixed income is the investigation of optionality in the cash flow. So think in terms of callable bonds. Okay, but the option adjusted spread, this is the spread that takes out the effect of the embedded options. So I would call it, rather than option adjusted, I would call it the ORS, the option removed spread. Okay, and you can think of this as just simply saying, well, okay, if I calculate the z-spread, okay, that is still giving me too big a spread, right? So we went back to the last slide and we looked at our z-spread of 50 basis points. Well, if the z-spread is 50 basis points and the bond is callable, well, when is it going to get called? It's going to get called when it's not in your favor. If it's not in your favor, okay, well then you're going to end up losing some spread. So the option adjusted spread will always be smaller than the z-spread for a callable bond. Could be larger for a puttable bond, but the callable case is the more frequent. So all we're doing is saying, well, what is going to be the impact of the option on the return? And that's going to shrink down the spread. So that is the OAS, the option adjusted spread. We're going to talk about it in much more detail at level 2. All right. So a couple of things that you ought to know. The option cost, okay, that is the z-spread minus the OAS. So what happens if we look at it and we say, well, the z-spread is 50 basis points and the OAS is 50 basis points? well, then that's a non-callable bond. All right, so there's no difference there. So you can use, you don't need to use the OAS for a non-callable bond, but if you look at this and say, well, the OAS is 40 basis points, well, what does that say? We calculated the Z-spread as if there was no optionality. Once we account for the fact that the bond issuer may call this away from us early, then we really only have 40 points of spread. Well, the option cost us 10 basis points of yield. All right, so theoretically, the Z-spread and the OAS are the same for a non-callable, non-puttable bond. So the option cost is greater than 0 for callables and less than 0 for puttables. And down here, make sure you know this, and we'll talk about why at level 2, but you have to use the OAS if you have a bond that has embedded options. Okay, so OAS, call it the ORS in your mind. Okay, keep in mind what do we mean by option cost. If you'll learn what's going on here with the rules, the option cost is greater than 0. Okay, then it's callable. So that was 10, right? So we said this is 50 minus 40. Okay, that means that the call feature has eaten away some of your yield. If you do it the other way, then it's going to be adding to your yield. And if you're dealing with bonds with embedded options, which you won't be dealing with much at level 1, you may need to know what a callable bond is. Okay, but we don't have quite enough rigor behind what we're talking about to really dig into embedded options yet. So nominal spread, just difference in yield to maturity. Z-spread, the increment you add to every spot rate on the theoretical spot rate curve. The OAS is what happens to the Z-spread once you take away optionality, but we don't have to calculate that at level 1. All right? Okay, so getting nearer to the end of this reading now. This is the next several slides. I think they get kind of tedious. We'll see some approximations, which are actually very good. We'll talk about the exact answer, but the approximations may be enough to get you the right answer on the exam. So if you get bored of this or you just don't like it, well, then maybe you just want to fall back on the approximations and hope that that's going to be close enough. You'd certainly miss a question because of it. I'm not saying it's foolproof, but it is at least pretty good. All right, so forward rates. So remember, we got yields. Okay, we discount all the cash flows in a bond at one interest rate. That's a yield. We have spot rates. That's a rate we take one cash flow in the future and we discount it back to today. A forward rate is a short-term rate that is expected to exist in the future. Here is our notation. Notation is going to be important, right? So the 1F0 is the 1 year forward rate 0 years from today. Well, let's see. 0 years from today is today, right? So the 1 year rate today is just the spot rate. So S1 is the spot rate for 1 year today. The 1F1 is the 1 period rate 1 period from now. Okay, if you get this one down, right? So if you get this definition, that'll help you with the notation. The 1F2 is the 1 period rate 2 periods from now. So the 2F1 is the 2 period rate 1 period from now, right? So the first number, the first subscript is the duration of the rate or the time over which the rate is covered. The second number is when the rate would begin. So the 1F2 is the 1 period rate 2 years from today. All right. Now, the thing that the point we're trying to make over really the rest of this reading is that spot rates and forward rates are linked, and they're linked by arbitrage, and so this has got to be true, right? So if we looked at the 3-year spot rate, and here we're assuming that this is all based on annual, probably should have done it semi-annually, but anyway, on annual rates. Well, let's see, what is the discount rate going to be, or what's the return that you're going to earn over 3 periods? Well, 1 plus the 3-year spot rate raised to the 3rd power. Well, the point is, and this comes out of the theory of term structure that we don't have to worry about here, but that is called pure expectations. It says, well, the longer term rate is just going to be a function of the shorter term rate. So here's the 1 year spot rate, the 1 year forward rate 1 year from now, and the 1 year forward rate 2 years from now. That covers 3 years, right? 1 year spot rate, 1 year forward rate, 1 year forward rate 2 years from now. So these two things have to be the same, and it doesn't matter how you slice them up. So the 2 year rate 1 year from now, that covers what period? Okay, well, we're talking about starting today. Here's time 0. All right, so that's where the spot rates are. So that'll take us out here to time 1. Okay, here's 2 and 3. Well, this is covered by the spot rate, and then the 2 year forward rate 1 year from now, well, here's the 1 year from now, so that just says the second chunk that takes us from 1 to 3. So that's that is the 2F1, right? And we could also do it as, you know, the 2-year spot rate and then the 1F1 over there. So I guess we can get enough things gone here. So if we have a 2-year spot rate, that takes us from 0 to 2. And then the 1-year forward rate 2 years from now would be right here. Well, the returns have to be the same. All right, that's all this is saying. So this is the link between spot rates and forward rates, and this is really the key to most of the rest of the reading. So looking here, I can get my slide to advance. So forward rates. So forward rates from spot rates, well, let's see. We have the spot rate for 2 years, the spot rate for 3 years. We want to calculate the 1F2. Well, what you need to calculate forward rates is bracketing rates. So in this case, we have a 3-year rate, right? And we have a 2-year rate, which you can't hardly see. Well, that's the bracketing rate. So if you have the 2-year rate here, you have the 3-year rate here, then you can find the implied 1-year forward rate 2 years from today. And the way you do this, and I know looking at all this math, it looks sort of big, but we're going to de-annualize. So this is 1 plus the 3-year rate. There's a 3-year rate. Raise it to the third power. That says, well, what's going to be your total return over 3 years, right? So that's de-annualization. So that would be a 3-year rate in the numerator, but that's the rate for, you know, no compounding for a 3-year loan, right? So 3 years. Well, this is for 2 years, the 2-year spot rate squared. So what you're really doing is you're going to de-annualize, okay? So I'm going to write up here as DA, right? So you de-annualize, okay? And then you're going to take 1 plus the big number, okay? And over 1 plus the small number, okay? And that's going to give you the part in between. So if you got 3 years and 2 years, well, 1 plus the big over 1 plus the small is going to give you the implied forward rate. And then step 3 is just to take this back and, you know, talk about it whatever terms you want to talk about it in. You know, if it was not 2 and 3. Since it is 2 and 3, you'll get an annualized rate. But if it was not 2, what if it was 2 and 4, like we'll see on the next slide? Or if it were 90 days and 180 days, then you would have to re-annualize, right? So the last step would be to re-annualize down here, RA. Okay, but anyway, so de-annualize, take 1 plus the big number over 1 plus the small number, and then re-annualize if you need to in order to get to the forward rates. So what do we have here? 1.05 cubed over 1.04 squared. Then we take, of course, subtract back out the 1, and that gives us 7.03. What is that saying? Well, really all that's saying is, look, if you earn 5% for 3 years, what are you earning? 15%. On the other hand, if you earn 2% for 4 years, you've earned 8%. Under the arbitrage pricing here that would deal with the pure expectations theory, it says, look, you can invest for 2 years at 4%. Well, I guess what it says is it doesn't matter how you divide up your time horizon. You can either invest for 2 years at 4% and then buy another 1-year bond, or you can invest for 3 years at 5%. Well, here you're going to earn 15%. Here you're going to earn 8%. Well, if you have to earn the same rate over all 3-year periods, then it's 15 minus 8 tells us that the 1-year forward rate has to be 7%. So notice that it is off at the 100th place, right? So this is pure expectations. We don't need to worry about that now. But that says here's 15% for 3 years, 8% for 2 years. That means that if you're going to invest for 2 years, you're only going to earn 8%. You've got to earn 15% eventually over 3 years. Then in that third year, the 1F1, okay, not the 1F1, the 1F2, the 1-year forward rate 2 years from today has got to be 7%. Okay, now in this case, we have a 2-year spot rate and a 4-year spot rate. We want the 2F2, but remember, that's got to be annualized. So we're going to do the same thing. We're going to take the number and de-annualize it, 1.05 to the 4th power, 1.04 to squared. But in order to annualize it, we've got to take the square root, right? So that would give us a rate. This would give us the 2-year rate 2 years from today, but we need it stated annually, right? So in this case, if you have the 4-year rate, you're earning 5%. Well, what are you earning? 20%. If you have the 2-year rate earning 4%, you're earning 8%. That means in the following 2 years, you invest for 2 years at 4%, earn 8. If you're going to earn 20% over the 4-year period, 20 minus 8 is 12. But that is a rate that covers 2 years. You need an annualized rate. So if you divide that by 2, that's where we get the 6. And once again, you can see 6 here, 6.01. this approximation is pretty good if the yield curve is not too steep and we're talking about short enough terms for the bond. So that's the idea behind that. Okay, so what about spot rates from forward rates? Okay, well here we can also remember that the spot rate is the geometric mean of the forward rates. So if you want to go, if you have the 1-year spot rate, the 1F1 and the 1F2, well, just find the geometric mean of that, which we talked about back in study session 2, and that'll be the 3-year spot rate. So all this, and again, this all gets back to the point that it doesn't matter how we divide it up. If we're looking at a 3-year period, we can divide it into 1 plus 2. We can take 2 plus 1, or we can take it over the whole 3. But when we look at the whole 3, then the returns have to be the same. All right? So if we have a 1-year spot rate of 4, 1F1 is 5, 1F2 is 5.5, all we're going to do is find the geometric mean, and that is going to be 4.8314%. What does that say? Well, let's see. If we had a spot rate of 4.8314%, so we had a cash flow 3 years from now, we could discount it back 3 years at 4.83%. Okay, or we could discount it back 1 year at 5.5, 1 year at 5, and 1 year at 4, and get exactly the same answer. So this one we'd have to, of course, end up cubing it, right? So we discount it back 3 years at that rate. We're going to get the same answer either way. What about the approximation? 4 plus 5 plus 5.5. Take the average, because there's 3 of them. Well, that's 4.833. Once again, you see that the approximation does a pretty good job here, right? All right, so that is spot rates from forward rates. Just a couple more slides. I know you're getting tired of this. So valuing a bond with forward rates, well, the 1-year rate is 3, the 1F1 is 3.5, the 1F2 is 4%. All this says, going back to the last slide, is look, we've already done this where we've said let's take the cash flows and discount them back at the individual spot rates, right? So we've already done that. There's nothing new there. Now all we're saying is if we know the 1-year spot rate, the 1-year forward rate 1 year from today, and the 1-year forward rate 2 years from today, we can work backwards into the spot rate. So this is nothing but the 3-year spot rate cubed. Okay, this is the 2-year spot rate squared up here, and this is the 1-year spot rate. So all we're doing is working backwards here from the forward rates into the spot rates to come up with this value for the bond of 1,014. And I realize that that is a lot of calculation, a lot of exponents, all that sort of stuff. But once you get down the idea that it doesn't matter how you mix and match, okay, so if you got 3 years, you can buy a 1-year bond, a 1-year bond, a 1-year bond. You can buy a 2-year bond and a 1-year bond. You can buy a 1-year bond and a 2-year bond, or you can buy a 3-year bond. Doesn't matter how you slice up the holding period, the returns all have to be the same over the 3-year period. Well, then that insight will allow you to work backwards and forwards between forward rates and spot rates. And to close things out with a question here, current spot rates are the 1-year rate is 6%. Now remember, these are spot rates. Okay, the 2-year rate is 7% and the 3-year rate is 6%. The 1-year forward rate for a loan 2 years from today is closest to what? Remember, we're going to de-annualize, DA. Then we're going to do what? We're going to take 1 plus the big number over 1 plus the small number. So let's see, the big number, that's going to be, let's see, 3 years at 6%. So let's see, that's going to be 18%, right? Okay, so there's 18 there. Let's see, the 2-year rate is 2 years at 7%. So that's going to be 14%. Okay, well, in this case, the approximation is going to tell us that we need a 1-year forward rate. 1-year forward rate 2 years from today has got to be something very close to 4%. So here's the, there's the big number, 1.06 cubed over 1.07 squared. Okay, we're going to take back out the 1. That tells us 4% here. But as you can see, my little approximation, that was 18 minus 14, actually works pretty well to get us to this answer of 4%. All right, so that is this reading that, again, some people find to be a little more difficult. So remember, what is the relationship between forward and spot rates? Okay, do you understand the spot rate curve? Do you understand bootstrapping? If you do, then you've got a lot of this stuff down, and I think you'll find with a little bit of practice you can get on top of this, even if it appears a little more cumbersome at the outset.